Okay, here I am for part 2 of Transformation Tasks Homework Help. We just did this example, and now I'm going to go through really the rest of it just to kind of give an overview. So in question 2, it says this triangle ABC is plotted, and so is triangle A double prime, B double prime, C double prime. Well, right away we can see, without even seeing what they're going to ask us, we're missing the prime ones. We're missing the A prime, B prime, C prime triangle. So that's what they want us to do, is describe 2 translations to move this from here to here. So here's what I did, but this is not the only thing you can do. Obviously there are there's at least one thing I can think of you can do. So here is, this is what I did. I translated mine using this rule, x minus 4, y, which means that I'm just moving all my x values -4, and I'm not moving up or down. I'm not moving y values. So I end up here, and then I do a reflection over, and then I want to ask you guys, what line do you think that is? So remember my rules about how I describe these lines? It's either going to be y equals something or x equals something. So if we basically, to describe the line in its equation form, we have to find where that line crosses over the x or y axis. And right here it's crossing over the y axis. And it's crossing over the y-axis at -1. So we're going to say that it's y equals -1. So it's a reflection over y equals -1. It's important that you write it out like this and not just y minus 1, because that's not what this is. So we translate it and then reflect it. Okay, and on the back, there's a series of questions about congruence and similarity, and I want to talk about it briefly. So in general, we know that a rigid motion, or here, I'm just have you guys look at me here. A rigid motion, in other words, a reflection, my famously amazing drawings, a reflection always has congruency because it's a rigid motion. It's not going to transform or anything. I just realized I might be upside down while I'm talking to you. This is crazy. Okay, and then a reflection does. So does a rotation, because it stays the same exactly. And then, as you know, a translation, moving over and up, a translation is going to be a rigid motion, and it's going to stay the exact same shape. So it's similar. So we can say that the only transformation that changes shapes. I'll put this back. I have a feeling I was just upside down right there. That's going to be really funny to see that later. Just FYI. So a rigid motion, or the only thing that's not a rigid motion, is going to be your dilations. So dilations produce similar shapes because their sizes, like this here, the sizes are proportionally bigger. So if you see, you can compare any 2 side lengths, and you're going to see that the sides are the factor that you've increased your shape bigger. So if this is 1, 2, 3, that's 3 units. Then here this is 1, 2, 3, 4, 5, 6 units. Wow, that's a dilation factor of 2, isn't it? So the angles are the parts of the shape that are always the same. So those don't change. A and A, those are exactly the same. Actually, B and B go like that. So, so what you should know is that anytime you have a dilation, the dilation makes it similar and not congruent. It's not congruent. the parts of your shape that are the same, or the parts of your shape that are congruent, are the angles, and the parts that are similar are the side lengths. So I hope that clears it up. And also I figured this one out too because it was really fun. So what do I do to get this to match exactly to its double prime shape? So you have to do a rotation 180 degrees about the origin, and this shape here would be over this one. And then you have to do a dilation to a factor of 1/2. As we discovered here, this side length is half of that. Since this is the resulting image, we have to dilate it by 1/2, or divide by 2, which is another way of thinking of it. Okay, that's it. Good luck. See you tomorrow.